The basic theory of liquid-liquid extraction is relied on the differential solubility of pigment in immiscible solvent. So there are two solvents used, a non-polar solvent and the polar solvent. The two layers were found based on their density. Then the pigment rich hexane layer is separated for further analysis. The modern technique compared in this experiment is HPLC. So the HPLC is able to identify and quantify the pigment component based on their quality and the retention of the color metric under the high pressure. So for accuracy, the HPLC provides the high accuracy and specificity, while manual extraction may result in pigment loss. For the efficiency, the manual method are efficient, while the HPLC provides better separation and quantitative capability. For the separation time, the manual extraction is quick for bulk pigment recovery, while HPLC has longer runtime to deliver the detailed result. For the operational cost, the manual method are very affordable, where HPLC require the expensive instrumentation and the maintenance. For the accessibility and the handling skill, the manual extraction can be performed by the beginner, where HPLC require the technician. There are two project goals in this experiment. So the first is to extract the colored pigments from colored discs using the simple solvent extraction method. And next is to separate and identify the major pigment components such as the chlorophyll A, chlorophyll B, and the carotenoid by comparing the RF value and the color with the standard. So for the part A, the preparation of colored disc paste, the colored discs are washed and then whitened dye. And then the 10 grams of colored discs are ground using a mortar and pestle to form a coarse paste. For the part B, the extraction with the solvent. So the paste is transferred into a clean beaker. 40 ml of hexane is added and stirred for 15 minutes using a magnetic stirrer to dissolve the pigments inside the beaker. For the part C, the filtration of solid residue. The mixture is filtered through the filter paper into a clean beaker to remove the solid leaf residue, and then the filtrate is collected, which containing the pigment-rich organic extract. For the part D, it's a simple solvent technique using the separatory funnel. The filtrate is transferred into a separatory funnel, so by adding the 40 ml of distilled water into it. The separatory funnel is shaken gently for 1 to 2 minutes and vented periodically to release the pressure. The funnel is allowed to stand for 3 to 5 minutes until two distinct layers are formed. The top layer is hexane, while the bottom layer is the distilled water. The upper layer is collected in a clean and dry beaker, and the lower layer is discarded or retained it for the comparison. Now, I will compare the step using the modern technique, that is the HPLC. So when a sample is injected into the HPLC system, the mobile phase carries the sample through the column. Inside the column, different compounds in the sample interact differently with the stationary phase based on their polarity, size, or chemical structure. This causes them to travel through the column at different rate, leading to separation. A detector at the end of the column measures the compound. So in the industry application, in the food industry, the HPLC ensure the consistency and the safety of colorant and the flavor compound. In the pharmaceutical, the HPLC is essential for lab purity testing and the formulation control. In the cosmetic, the HPLC can be used to analyze the extract for their pigment or the antioxidant content. In the environmental testing, the HPLC detect the trace level of pollutant in the water and the soil sample. For the sample analysis, TLC method is used. 5 ml of the TLC developing solvent in where contain a mixture of hexane and acetone in the 7 to 3 is prepared in the developing chamber. In the TLC plate, the two lines around are drawn with a red pencil, 0.5 cm from the bottom of the plate and the 5 cm up the plate from the first time. A microcapillary tube is used to load the extract onto the TLC plate by allowing the tip of the rod at the end of the capillary to just touch the plate. The chamber is covered and capped immediately to avoid loss of solvent saturated atmosphere. At the same time, the solvent begins to migrate out the plate. The plate is allowed to rise once the solvent reaches the top line. As the plate rises, the changes in appearance is observed. The RF value is calculated based on the formula shown. The distance traveled by pigment over the distance traveled by solvent. The RF value calculated are compared to a literature for the identification of each pigment. For the blue-green color, the pigment is the chlorophyll A with the 0.36. For the green color, the pigment is the chlorophyll B with the RF value 0.4. For the gray color, the pigment is phenolphthalein A or B with the RF value 0.5. Well, for the yellow spot is acid the upper line due to the overdevelopment. The possible identification of yellow spot is carotene because the carotene is a non-polar and it tends to travel very close to the upper line of plate. comparison advantages and disadvantages between the manual technique and the high-end instruments. So the manual technique is low cost, accessible, and simple setup. However, the manual technique is less accurate and may has handling error. For the high-end instrument is very accurate and efficient. However, it is expensive and require the technician to operate it. For the industrial implication, the industry will prefer the high-end instruments because it's better for quality control, regulatory compliance, and also the consistency and also the stability. For the manual techniques are still relevant because for the educational purpose in the lab setting, and it also the preliminary testing or in the resources limited situation. For the conclusion, the simple solvent extraction method applied has been successfully demonstrated to isolate the color pigments from the color leaf. So the major pigments such as the chlorophyll A, chlorophyll B, and the carotenoid were successfully extracted and identified based on the RF value and color characteristic. Although the method is cost-effective and accessible, it has certain limitations, such as the potential pigment loss during the handling and the inability to provide the quantitative data. In contrast, the modern analytical technique like HPLC offer the high sensitivity, reproducibility, and compound-specific analysis. This making ideal for industrial and the research application. The comparison highlights the importance of technique selection based on the goal of the analysis. For the crude pigment extraction and basic identification, the manual methods are sufficient. However, for the detailed quantification, the compound purity assessment and stress level detection, the HPLC remain the preferred method.